In this video, we'll be looking at exponents of 0 and exponents that are negative as well. We're going to look at why they are the way they are, and we're going to just work with a few examples. So let's start by looking at exponents of 0. So let's just call them 0 exponents. Alright, so there is a rule that states that any number, let's call any number a for any, to the power of 0 will give you 1. Any number to the power of 0 gives you 1. So it doesn't matter if you said like 3 to the power of 0, for example, is 1, or 1092 to the power of 0. Still 1. Any number to the power of 0 is 1. And that's a rule. You may be wondering why. So if you are wondering why, let's go over a little baby proof here. It's not a real official proof, but just so you know, something to so you can see why. All right, if I have a, for example, to the power of n, and I divide it by a to the power of n, my a to the n would cancel and I would get 1 over 1, or just 1, simply. All right, well, what does that have to do with anything? Let's try the same thing again. A to the power of n over a to the power of n. If you remember your laws of exponent, that's actually equal to a to the n minus n, which is actually equal to a to the 0. I did the same problem twice, right? A to the n over a to the n, a to the n over a to the n. In one case, I got that it was equal to 1. In the other case, I got that it's equal to a to the 0, which means that a to the 0 is, in fact, equal to 1. Any number. This works with any number to the power of 0. So that's kind of really important to remember, that anything to the power of 0 is always 1. There is a slight exception. 0 to the power of 0, that brings about many arguments. I will just say for now that 0 to the power of 0 is undefined, but anything else to the power of 0 will give you 1. So negative numbers are slightly more tricky, but they're not so bad. So let's go over the rule and then talk about why it works. All right, so if we have any number, let's call any number a, and we raise it to a negative exponent, well, in order to make the exponent positive, we have to move it from either the numerator to the denominator or the denominator to the numerator. So for example, we don't see a numerator or denominator here, so we can just, stick one in there. So it's just over 1. Since it's not over, you can't see what it's over. It's just over 1. Okay, so we take that and we bring it down, and once we bring it down, the sign of the exponent changes. So this is actually equal to 1 over a to the positive n. All right, so let's look at another one before we see why it works. If I had, for example, let's put this over here, 4 a to the n to the negative n, that would be equal to, and we're only moving the number with the exponent down, so that would actually be equal to 4 over a to the n. Okay, but why does this work? Well, if you want to see why it works, I'll show you a quick explanation here. All right, so if we have a to the negative n, that's actually the same thing as a to the 0 minus n. Do you agree? All right, I hope so. All right, so if you remember the laws of exponent, you would know that a to the 0 minus n is actually a to the 0 over a to the n. And we know that anything to the power of 0, we just spoke about that, is actually 1. So this is equal to 1 over a to the n. So now we can see why a to the negative n is actually 1 over a to the n. All right. Let's put these two pieces of information that we just learned about 0 exponents and negative exponents together and simplify a pretty little equation or expression. So if you're asked to simplify this expression, you're being asked to simplify it and get rid of the 0 exponents and get rid of the negative exponents our minds don't wrap so well about around zero and negative exponents. So the first thing that I want to do personally is get rid of that zero exponent. So we know that, I'm just going to rewrite everything else. We know that everything to the power of 0 is 1, so I'm going to replace a to the 0 with 1. And then I'll rewrite everything else. Okay, now, that said, we know our negative exponents will take those values raised to those exponents and bring them from a numerator to a denominator. So it may help to actually see a denominator. So let's put that over 1. So we know that if we take this and we pull it down, the sign of the exponent changes to positive. Same here. Since we have a negative exponent here, we can pull it down and the sign of the exponent will change to positive. So we get 1 over 2 to the positive 1, and we don't have to write that 1 because it's implied, times b to the positive 3. So I just moved this down to here and changed the sign of the exponent, and move this down to here and change the sign of the exponent, and we're done.